Well, hello viewers, this is Alexander from Media Search Program. Today I'm going to show you a simple example of UDP NAT Hole Punching, and NAT being Network Address Translation. And of course we will not be setting up any port forwarding whatsoever. This is simply a very simple example of how two freeLAN applications can communicate between each other without absolutely opening no ports, no forwarding ports of any kind through our NAT devices. Now, to give you a simple description of what NAT is, well, before I get to this part of here, let me tell you what NAT is. NAT stands for Network Address Translation, and basically allows a router to modify packets to allow for multiple devices to share a single public IP address. In maybe rudimentary terms, you can also call it a masquerading firewall to some extent. So basically it hides the internal machines behind a NAT device, which is a router or a gateway. You can call it what you want, but basically it acts like a masquerading firewall. Anyway, the application I'm going to be using is actually freeLAN version 2, and we're using a 64-bit binary. Now, getting to our network topology, well, this is my local machine, okay? Running on the 192.168.0.0/24 subnet, and this is an Amazon EC2 server running in the United States, and its IP address is on the 172, basically 172.31.40.175. It's on that subnet anyway. It's definitely behind NAT, okay? The public IP address, I'll get to that a bit later anyway, but this is a private IP address, so it means it's behind NAT. This is a public IP address, which means it's in front of it, okay? And if we go to my end, obviously we are now in Australia. This is 124.190.15.178. So this is my public IP address on my router, okay? It has nothing to do with my computer, okay? Because my computer IP address is 192.168.0.194. So, get into this part over here. How on earth am I going to accomplish this without port forwarding? And the question, basically the idea is how Skype or torrents work or video conferencing works. We basically take the advantage of peer-to-peer. Now, we don't have any super nodes here, so we're basically punching holes directly through these two masquerading firewall devices, also known as NAT. So let's get into it. So let's start up a Wireshark over here. We're going to be using UDP source port 12,000 and the destination port 12,000. But before obviously nothing is happening here. So what we're going to do now is I'm going to show you basically the freeLAN configuration. Okay, so basically this is the freeLAN configuration. We basically have a metric of 3. We have an IPv4 address. We're signing it to 10.0.0.1/24, and this is our IPv6 address to AA1:1. Okay. Now let's go to our FSCP configuration part. So Control F, FSCP. Okay, and we'll scroll down. As you can see, we're listening on any 12,000. And we're going to contact basically this machine over here, 54.186.60.6. Now this is actually the NAT device of Amazon, okay? Because remember, if I go to the physical properties of this computer, which I will show you right now, the IP address of this machine is 172.31.40.175. So basically this is obviously on a private LAN, okay? So we're not actually on the public side, okay? So 54.186.60.5 is actually some sort of NAT device in Amazon. Now I'm not sure exactly how Amazon completely works, but I do understand the basics basically of a masquerading firewall. In this case, this is obviously some sort of masquerading firewall, because the IP address of this machine, if you were to reboot it, you'll get another public IP address. So I'm therefore hypothesizing that there must be a NAT device / masquerading firewall on this Amazon networking thing. But anyway, let's get to the practicality. Metric 3, 10.0.0.2, 2AA 1::2. Let's go to a FSCP. Control F. FSCP. Let me just try clicking again, registering our mouse clicks, because it is going through a remote connection. Okay, listen on any 12,000, and this time we're going to contact 124.190.15.178. Now you might be asking to yourself, okay, well, since this is not my computer, it is my router, and my computer is behind the router, how on earth does my computer know? How on earth does it know to go to my computer directly? Well, UDP NAT Hole Punching, basically what it basically does, it basically tells the router where to forward the packet. Now the reason why this works, basically, typically you've got a super node. So for example, in Skype, you establish a connection to a Skype server. Okay, when you establish a connection to the Skype server, Skype basically does what's called a NAT transversal technique. Now, I don't want to go too much into details what it's all about, but the idea of NAT transversal is to have a peer-to-peer connection. So imagine you have two people talking on Skype, one on Sydney in Australia and the other one in Brisbane, Sydney, New South Wales, Australia, and Brisbane, Queensland, Australia. Okay. Now it would be pointless to reroute that voice communication for the United States to come back down to the actual end user. That's a huge latency. By establishing a peer-to-peer connection between Sydney, New South Wales, and Brisbane, Queensland, okay, you decrease the latency by a huge amount. So peer-to-peer applications, especially in voice and video, aka in conferencing, okay, obviously it will help a lot if NAT transversal works. Now keep in mind that this experiment will not work, this example will not work on symmetric NATs. Symmetric NATs basically randomizes, well it does modify, but it randomizes the source port. So therefore, no NAT transversal technique will work, okay? So it will work basically on non-symmetric NATs, okay? Of course, there are certain NATs that have special firewalls and all that mumbo jumbo, you know, and that might actually, you know, be more intelligent to make this experiment not work, okay? But let's be rudimentary and let's be clear for you viewers who don't know exactly into detail, and I don't want to go into detail with this because it takes too much time. The idea of this experiment is to show how this works. So let's get to the practicality side of things. So I'm going to open up Freelan, and there we are. I'm sending a hello to this IP address. I'll open another one on my computer. So launch this one. Try again. Okay. So now basically we established a connection, and we should see it under Wireshark. Okay, so basically what we're seeing here is we're seeing a communication. Notice that that's our Amazon. Okay, and we can see Amazon and my computer talking. Okay, so how do we know if it's really worked? Well, remember the IP addresses I showed you in the configuration. Well, we can verify over here on our TAP interface. Okay, so my IP address is 10.0.0.1, okay, and the other end, whoops, not this one, let's have a look, is 10.0.0.2. So theoretically, I should be able to ping 10.0.0.1. Ping 10.0.0.1. There we are. So now my Amazon can now ping 10.0.0.1. Okay. Now let's have a look. The latest versions of RDP support UDP. Okay. Now because Amazon only allows a TCP connection of RDP, obviously this does not tell me my UDP connection status. It only tells me that the quality of this to the remote computer is good. So we know it's TCP. Okay, I'm gonna quit this connection, and we are logged into this server using 10.0.0.2. So let me launch remote desktop. We'll log into 10.0.0.2. Now I'll let it get my credentials. Connect. Type it in. Yes. And as you can see, we are now logged in through to Amazon using the FreeLAN connection. And now it says UDP is enabled. Okay, so by default, when a Windows server is created on Amazon, the RDP, you can RDP to it, but only in TCP mode. Okay, now I only enabled in the Amazon firewall only RDP TCP only. But since we're accessing through a different channel, you can see that UDP is enabled. That's because we are not using the we're not using this interface. We're using this interface to connect. This interface is the unlocked interface, and I can show you right now, because if I try to connect through a if I try to establish a connect, if I try to connect using this IP address to a share, it will not work. But I'll just cut to the chase. So now I'm in. This is Amazon. Okay, 10.0.0.2 equals Amazon. I have now gained access into the C drive, so I can see how dangerous this is anyway. Now, of course, this is just a rough example. FreeLAN is used for LAN gaming, but as I said, I just want to repeat here. No, absolutely no port forwarding was done in Amazon. No port forwarding was done in my home router. So all of this is working without port forwarding. We are taking the advantage of UDP NAT Hole Punching. Let's go to Wireshark and see why this works. Okay, we're now in Wireshark. Amazon, my computer. Okay, source port 12,000, destination port 12,000. What has basically happened is when both instances of FreeLAN were launched, okay, FreeLAN created a UDP hole through the Amazon firewall and through my router firewall. Now these are, and of course the NAT, of course they both act as NAT devices at the same time. So they actually created a hole. Because that hole was created, they were able to talk each other through using those holes that was created from the first time when the application was launched. Now, basically, if you were to do, if you know, BitTorrents, as I said before, Skype, they use the same principle, but they got a super node. Now we're not using a super node. We're not using a server. We're not using ICE, stun, turn. We are using nothing fancy. All we're just using is FreeLAN. Listen on this port, connect to this port, connect to this socket. So we're basically using a very simple method of UDP NAT hole punching. Now, of course, you might be saying to yourself, well, if port forwarding doesn't have to be done, could this have malicious purposes? Well, of course, there can be malicious purpose for this. You know, this could be one of the biggest Trojans on the planet, basically. No, but fortunately, it's not. Trojans and other malware do not use NAT transversal. Very few malware actually use NAT transversal. Most malware would use other forms like reverse tunneling, TCP connections, but in fact UDP hole punching or other forms of NAT transversal like UPnP or port control protocol or NAT PMT or whatever mumbo jumbo you want to call it, malware don't really use it that much. Okay, so don't worry about this. If you think this could be malicious, you know, I'm a network administrator and I can see access somebody else's network without port forwarding. Don't worry. This is how TeamViewer works. This is a normal thing. I'm just giving an example on how this works. Let's go to Amazon and let's see our connection. Let's see what's happening. Okay, so I'm going to look at this interface over here, 173.31.40.175. I remove promiscuous mode, and we're going to do a start. And let's see. Okay, so I stopped it because we're just going to capture a sample. Okay, so basically, this is Amazon. This is my home router / NAT device. Okay, so basically, Amazon is basically communicating through my router, which my router is then forwarding it to my computer. Okay, since a hole was created, the router knows where to forward it. Okay, so basically, in a nutshell, 172, okay, is transmitting to my public interface of my router, and then the public interface of my router is then transmitting that onto my computer over here. Okay, and the same thing is doing for Amazon. Okay, look, if you want to find more information about UDP NAT Hole Punching, you know, feel free to Google it. It's a good source over here. I can recommend to you. If you know, this guy apparently has done it. This one over here, I'll highlight it for you. So all you have to type in is UDP Hole Punching, and this video over here, UDP Hole Punching, how BitTorrent works. This is simple to understand. Keep in mind, this video he uses is he actually uses a HPing utility and netcat, and he uses actually a program to view as it goes through the NAT device. Okay, but his method, you know, works just like mine, but he uses, as I said, he uses HPing with netcat. In my case, because I'm using the Windows box, I had to use Freelan, but I'm guessing the advantage is, and this is my EC2 server over here. I guess the advantage with Freelan is with netcat and HPing, you're going to do telnet commands, which in my case, I can actually access a drive. I can create a new folder. Okay, so I call it actually, you know, hello. Okay, and if I go to my remote desktop, sorry, wrong one. If I go to remote desktop, you can see I created hello. Okay, and of course I can delete it. If I go to desktop, so I'll delete hello from Amazon. So 10.0.0.2 is Amazon, and delete the folder hello at Amazon. And now I go up here, and now the folder is gone. Okay, so I can do RDP as well. So there's lots of things, you know. So basically, this is UDP NAT Hole Punching. Basically, we are doing a VPN over UDP NAT Hole Punching, in other words. And what you got to remember is this can be a great tool to get two pieces connected to each other without actually port forwarding. However, it can be a worse nightmare, because this could be, you know, some form of Trojan that doesn't need any access to your router. It simply just needs to punch holes through your firewall / NAT device to get access. But of course, this will not work with symmetric NATs, because symmetric NATs do randomize the source port of each packet. Okay, so the source port of a UDP data stream, instead of being 12,000, could be 56,590, and therefore the experiment on this example I've shown you will not work. Okay, and by the way, symmetric NATs are used on enterprise networks. Symmetric NATs do have the advantage of masquerading, how can I put it, masquerading fingerprints of OSs, but I don't want to get too far into this. You can actually fingerprint an operating system by the source port algorithm. Okay, symmetric NATs basically just re-randomize it again to masquerade an OS algorithm fingerprint. But I want to get to that stage anyway. I just want to show you about UDP NAT Hole Punching and how I can connect to Amazon, and how Amazon can connect to me, and how we can basically talk to each other without opening any ports. I hope this video has been interesting. I hope you learned something from it. Feel free to leave comments on YouTube. I could post more videos on this. Actually, you can do this. You can actually do this at your home network. All you need basically is a network, an extra 2 NAT devices, and you can do it in your lab environment, or you could do it on a virtual machine. You can use OpenWRT for VMware, and you can just use VMware as your virtual network in lab environment. Okay, well, I'm gonna go because I'm talking too much here. Thanks so much for viewing, viewers, and I hope you enjoyed this session on UDP NAT Hole Punching, and I'm guessing maybe on firewall bypassing as well, if you want to put it that way as well. Anyway, thanks so much, viewers, and enjoy. Bye.